Good morning, students. My name is M. Shekhar, Assistant Professor, Department of Mathematics, Erode Arts and Science College, Erode. Today, going to discuss about work, energy, and power. What is work? Work, if an object has energy, it can do work. Work is a transfer to energy from one place to another place. Work is done by force when it moves an object. Work equal to force and distance. Distance must be consistent or if not use components. The force in newtons. Units of force is a newton. Distance is calculated a meter and work is a joules. Now the example of the given figure, the horizontal, that is given horizontal plane is a normal plane. The force or the particle put on the plane, the force is give the box is moved to one place to another place. That is calculate the work done by the force. Now work is calculated for work done force into distance. Force how many force is given the particle into how many particle move to distance is multiple is a work done. Work done is a formula for force into distance. Sum of works done is against a friction. Friction is, the two particle contact to perpendicularly that produced a friction. Here F1 is and X2 are same direction. Work done against a friction plus work done against the gravity and kinetical energy is gained. Work done of given distance of y is calculated formula is work done against friction plus work done against gravity plus kinetical energy is gain. Now the kinetical energy is the formula for half into mv square. Now and potential energy is calculated mgh. M is mass, g is a gravity, h is a height of given height. Is now the potential energy equal to zero. The gravitational potential energy is an object of an object. M is denoted mass, g is a gravitation, I is a height. The unit of calculated for that energy is like measured is a joules. Now there and also kinetical energy is measured by m is denoted the mass, v is a velocity or not a velocity, v is a speed. Speed is a magnitude of the velocity. The particle how many distance to move is calculated to the speed. The mass is the delta, the change of rate of change of the particle. Now is compared to that gravitational potential energy, two different particle, the work done is against the gravity mg into h2 minus h1. If h1 equal to 0, the kinetical, the gravity potential energy is mgh. Now kinetical energy, the accelerated particle for the rest, that is the formula for force into distance equal to mass. Now there mass and mass is a move to the distance between further using the straight line acceleration motion formula v square minus u square divided by 2. Now calculating for that formula f u squared is a rest, the particle is rest, the point is 0, so remaining half into v square divided by v square or half into mv square, that is calculated for the kinetical energy. Now, given formulas, given values there, you have to find out what is kinetical energy. For example, 10 kg mass, 5 meter distance or speed. Now, there what is kinetical energy? Then we are going to applying for the kinetical energy formula. the kinetical energy formula is half into mv squared. Now half into mv square, if you take the particle half into mv square, half into mv square, half m here 10 and v is a 5 the whole square. So 10 and 2 are cancelled, so 5 cube, 25 into 5, 25 into 5, 125. The kinetic energy is a 125. So same similar values is take, we find out the kinetical energy. The next one, the laws of conservations of energy. The laws of conservations of energy. The total energy of an isolated system remains of constants. Now there, the calculating for conservations of energy, initial energy and final energy. Now, if you take the particle in done by work in plus initial kinetic energy, initial potential energy, which is equal to final potential energy, final kinetic energy, and final workout. Sum of initial energy is might have been stored in the engine. For example, of battery that does the transfer into energy one particle to another, one particle to another. Using formula we get, for example, the work done of the particle calculated from conservations of energy. The formula, the force into distance plus half into mv square plus mgh1. Now work is a driving and initial kinetic energy half into mv square. Initial potential energy mgh1. The final, which is equal to half mv squared, is kinetic energy, mgh2 is a potential energy, work done, resistance of the distance. That is work energy principle formula. Now, conservations of energy is given the problem. We have to applying that values there and the calculated work done of conservation of energy. Next, power. Power is the rate of doing work or energy is input per unit time. Input of unit time. Power, that is how many, if you take the particle, work is done by is calculated to rate or energy input per unit time. Per unit energy, the work done by the given energy, that is called the power. Thank you so much.